Assalamualaikum. I will present to you about introduction. Vanilla is one of the world's popular flavor extracts. It is one of the most widely used flavor resources in confectionery, food, and beverage. For example, is vanilla essential oil. The high demand for natural vanillin for exceeds the supply from all sources. The high demand for natural vanillin far exceeds the supply from all sources. Many HPLC techniques have been developed during the past 20 years focusing on quantification of vanillin. Next is the flavor of vanilla extracts does vary considerably, depending primarily upon the country of origin, but also upon crop year, curing techniques used, storage conditions, extraction method, and age of the vanilla extract itself. In this research, the curing techniques use three methods: scalding in hot water, drying in the oven, and drying in the sun. The objective of this work is to analyze vanillin in vanilla extract by HPLC method.
Assalamualaikum, my name is Faris Sokman bin Ibrahim and I will explain the methodology. First is the sample preparation. Vanilla sample from about 1.5 kg was cured by three methods. X1 is scalding in hot water at 65 degrees Celsius for 30 seconds. X2 drying in the oven at 60 degrees Celsius for 48 hours. And X3 drying in the sun for 20 days and 2 until 3 hours every day. Cured vanilla was fermented and dried in the wind. Therefore, the water rate content in the cured vanilla decreased from 55 until 65% to 25 until 30%. The signs that vanilla had dried were: vanilla color was super black or brownish black shine. Vanilla was deflected because water rate contained about 30%. Vanilla had characteristics, flavor, and fragrance. The last cured vanilla was stored minimum for 2 months. The results of cured vanilla were taken at random for pre-extraction. Weigh the whole cured vanilla Y1, about 10 g for the circulation extraction Z1 and 5 g for percolation Z2. Weigh the cut cured vanilla Y2, 2.5 cm, about 10 g for the circulation extraction Z1 and 5 g for the percolation Z2. Second is the extraction procedures. Extract the cured vanilla of pre-extraction Z1 in the circular extraction apparatus with 200 ml of the 99.9% ethanol for 60 hours. Then transfer into a 250 ml volumetric flask. Rinse the flask of extraction apparatus several times with small quantities of the 99.9% ethanol and pour the washing is into the volumetric flask. Made up to the mark with the ethanol and mix well. Extract the cured vanilla of pre-extraction Z2 in the percolation apparatus and Lemire. Submerge Z2 about 35 ml of the 99.9% ethanol in Erlenmeyer 100 ml for 1 night. Okay, next transfer into a 100 ml volumetric flask through paper filter. Rinse filter paper with 5 ml of the 99.9% ethanol and store this paper filter for use at second filtering. Result of the cured vanilla from first submerge was pounded into mortar, then submerged again about 35 ml of the 99.9% ethanol in Lemire for 1 night. After submerged 1 night, ethanol from the second submerge was fused with ethanol from the first submerge through filter, user paper filter, which used at first filtering. Rinse the cured vanilla with 99.9% ethanol and pour the washings into volumetric flask. Made up to the mark with the ethanol and mix well. Okay. That is high performance liquid chromatography HPLC UV spectrophotometric. The vanillin was separated on a reverse base C18 column used methanol acidified water 10 plus 90 and was detected at 280 nanometer HPLC apparatus was Shiatsu and UV spectrometric was Hitachi. The flow rate of HPLC was approximately 4 ml per minute. Fourth is preparation of standard solutions. The standard solution containing 0.5 until 4.0 ppm of each standard was prepared in 99.9% ethanol for HPLC. The solution was stored at -2 degrees Celsius until required for analysis. Standard solution for spectrophotometric containing 1.0 until 5.0 ppm of each standard was prepared in 99.9% ethanol. Lastly is the quantification of vanillin content. Vanillin content percent W per W is equal to C multiply with V and divide with W, then multiply again with 100%. C is the concentration of standard solutions in unit of ppm from calibration curve at HPLC or spectrophotometric method. V is the initial volume of vanillin solution in unit liter, and W is the sample weight in unit milligram.
Analysis, result and discussion. The table show the result. Table 1 shows the linear regression equation and correlation coefficient R of the peak area measurement for vanillin standard in HPLC technique, and of the absorbance is the ISO spectrophotometric assay method. Linear relations were observed for vanillin standard between 0 and 4 ppm with correlation coefficient of 0.997 at HPLC and between 0 and 5 ppm with correlation coefficient of 0.999 at UV spectrophotometric method. Next, vanillin content percent weight per weight by the HPLC technique and the ISO spectrophotometric, which is the weight pure vanilla were 10 gram for lactation and 5 gram for percolation, is shown in table 2, which is 12 treatment of vanilla sample was determined.
Table 2 show the amount of vanillin for 12 samples determined by HPLC technique and the ISO spectrophotometric assay method. The data show that for the 12 vanilla sample analyzed, the spectrophotometric assay consistently yield higher values than the HPLC technique. The possible explanation for this: in the spectrophotometric assay method, vanillin is not pure and absorbed at the same wavelength area. This will cause high absorption. Although HPLC use detector UV, but the sample goes through C18 column and it is separated before it comes to detector cell. This causes only vanillin which is detected, and this also indicates relative smaller analytical result. However, the accuracy of this method is much better. The use of UV spectrophotometric can be more accurate if a sample is separated firstly, such as using special chromatography column. This way will obtain the same results with HPLC method with standard deviation less than 1%. The objective of the vanilla curing the curing with scalding in hot water or drying in the oven or drying in the sun was to stop vegetation growth and to change enzyme form vanilla flavor. From table 2, it can be seen that the highest vanillin content is at scalding in hot water. The cut cured vanilla and solidification extraction then follow with drying in the oven and drying in the sun.
Okay, Bismillahirrahmanirrahim. For the conclusion, the pre-extraction treatment for cured vanilla sliced about 2.5 cm resulted in higher vanillin content because there is direct contact perfectly between vanillin component in vanilla sample and extraction solvent. The vanilla content resulted from the subsilation extraction is higher than from the percolation extraction. This occurred because there is continually solvent purify process in the subsilation extraction. Therefore, the density of the vanillin content in vanilla extract is high. The HPLC method offers a more accurate means of determining the vanillin content of vanilla than the ISO spectrophotometric assay, because by HPLC method, vanillin was separated from other compounds.